Unit 3, Lesson 1, and we're diving right into quadratic equations. And so we're talking about two different forms of quadratic equations. Next to this problem, please write standard form. This is standard form. One thing really nice about standard form is we can easily identify the y-intercept. The y-intercept is always going to be this number in the very back. That's the constant. It has no x with it. So the y-intercept is 0, negative 11 as an ordered pair. Now I went ahead and I graphed this in Desmos, and we can see this is what it looks like. It's a parabola. Quadratic equations produce parabolas. Quadratic functions produce parabolas that either open up or down. So it's a U-shape up or a U-shape down. And so this is standard form. Today we're going to learn how to rewrite this in an equivalent form, but it's called vertex form. So today we're going to be using a process that's called completing the square. So please write down completing the square. And in using the completing the square process, we're going to rewrite things in vertex form. Vertex form is very handy when it comes to actually graphing an equation. So how do we go about doing this? If you are somebody who is brand new to this, feel free to write out all the steps. So the very first step is I'm going to write down this equation, and we're going to identify what the constant is. I need to take the constant and move it to the opposite side that contains the y. So to move a negative 11, I'm going to add 11 to both the left and the right. I'm left with x squared minus 8x, and it's always going to be plus a value. We'll learn about that why that's the case later, but it's always going to be plus a value. Now on the left-hand side, I cannot combine a y and 11, so it's y plus 11. This is a core standard in Algebra 1-2. We need to figure out what is this missing value that allows us to rewrite this in vertex form. And so to do that, what we're going to do is we're going to identify the b value. That's the value that's with the x. Not only are we going to look at the value, we're looking at the sign in front of that. And I want to have you put a box around that. You don't have to use a highlighter. Next up, I'm always going to take that b value, including the sign, and I will always divide it by 2, and then I'm going to square it. And whatever value I get goes into this position. So here's why it's always a plus sign. Because if this value was positive 8, well, 8 divided by 2 is 4. 4 times 4, if I take a value, it's positive, and I square it, I still get a positive. In this case, it's a negative. Negative 8 divided by 2 is negative 4. But when I take negative 4 and I multiply it by itself twice, I will always get a positive, regardless of what the value is. So in this case, we get a positive 16. Please write a positive 16 here. This equal sign means the left and the right must remain balanced. They must remain equal. If I randomly just added a plus 16 to the right, I need to keep it equal or balanced, which means I need to add 16 to the left. If I added 16 to the right, I must add 16 to the left. Now I'm going to combine like terms on the left-hand side. A positive 11 and a positive 16 gives us a positive 27. On the right-hand side, I do not want you to write down what I'm about to do. I'm going to do it the long way, and then I'm going to teach you the shortcut. Here is the long way. If I said to you, hey, I want you to use what we learned in September, and I want you to factor this trinomial, this is what you would do. I want you only watching. 1 times positive 16 is 16. What two values, if they occur, multiply to give you 16 and combine to give you negative 4? And you'd go through the list of numbers, and you'd end up with negative 4 and negative 4. They multiply to give us positive 16. They combine to give us negative 8. And then you'd factor it out. You get x minus 4 and x minus 4. And you go, oh, it's the same thing twice. I can write it as x minus 4 quantity squared. There's a way that we can cut this step out, and there's a shortcut. And here is the shortcut. Please pay close attention. I'm going to take these parentheses, and I'm going to widen them. I keep the square on the outside always. And I'm always going to put a single x in the middle, or sorry, in the front. I'm always going to put a single x in the front. Now, in this back position, I take whatever was in the parentheses. So negative 8 divided by 2 is negative 4. My last step is I'm writing this. This was standard form. Notice the y is isolated. So to write it in vertex form, the y has to also be isolated. So I need to move the 27 back to the right-hand side. So y equals the quantity x minus 4 squared subtract 27. I believe that this is the exact same function as the one up above, and I'm going to prove that to myself. So I come over here, and I'm going to write this in. Y equals, okay, in parentheses, x minus 4, quantity squared. Let me find that square. And then behind it, I'm going to do minus 27. And we see they're the exact same thing. It's one line on top of the other. I just proved to myself this is exactly the same. Let me come back here. Now, the nice thing about vertex form is we can quickly identify what the vertex is. So it lies to us. The vertex, by the way, as a quick reminder, if you've forgotten, the vertex is going to be the lowest point. So can everybody see the lowest point right here? It's the lowest point if that U-shaped parabola opens up. If the U-shaped parabola would open down, it would be the highest point. So how can I quickly tell this without graphing it? The x-coordinate of the vertex, it lies to you on the inside. And so instead of writing down -4, it's +4. It tells the truth on the back end. This is the vertex of this parabola. This is going to be the y-intercept. These are the exact same functions. They're just in different forms. That's example number 2. So I'm going to come up and graph this right away. Again, it's y equals x squared minus 10x minus 14. And I'm going to only look at what we see as the red function, this quadratic equation. And we're going to come back and we'll plug in what we think is equivalent to it in a few minutes. Okay, let's come back to this. What's the very first step? Our very first step is to take this constant. This is in standard form. We're going to move it to the opposite side. Opposite of subtracting 14 is adding 14. So I have y plus 14 equals x squared minus 10x. This is always going to be addition. Always is going to be addition. All right, what is the next step? Well, our next step is going to be to take whatever this b value is, and I'm going to always divide it by 2, include the sign, divide it by 2, and square it. Whatever I get goes into this position. So -10 divided by 2 is -5. If you're a visual learner, I'm going to take -5 and I'm going to square it. So -5 times -5 is a positive 25. In order to keep this balanced or equal, the left and the right side equal, if I add 25 to the right, I must also add 25 to the left. Let's combine like terms. I have 3 things here, but the 2 that I can combine would be the 14 and the 25, and I end up with 39. So y plus 39. Now here's the shortcut. I take this parenthesis and I expand it. I put an x by itself in front, not an x squared, just an x. Now what value goes in back? Well, -10 divided by 2 is -5. And my last step is to move the 39 to the opposite side by subtracting. So y equals x minus 5, quantity squared, minus 39. Now I want to go back to what I saw a lot of students doing in the previous hour. A lot of students mistakenly were putting a 2 right here. And I get it. They're like, well, it doesn't have to look like this, because if something's factored, it should be just equivalent. Remember, this is not true. But if we took this quantity, x minus 5, and I wrote it down twice, and then I went ahead and I FOILed this out. So I'm going to distribute. I multiply the fronts, multiply the inside, the outside, and the last. Notice that after I combine like terms, I would end up with exactly this. So we don't have to put a square there. It's just a single x every single time. Now here's where I can check to see, did I do it right? I come back here, and I'm going to write down this is x minus 5, quantity squared, minus 39. Notice how the red and the green right now, until I change this, are not the same. After putting a subtract 39, they're exactly the same. I just proved to myself it's correct, and I also can make sure that we did this right. So when I come back, my vertex for this problem should be at, it lies to me, the vertex. So +5, it tells the truth, -39. Also, the y-intercept should be at 0, -14. All right, so for this problem, I'm going to start by moving the 7 to the opposite side. +7 plus 7, I have y plus 7 equals x squared plus 12x plus some unknown number. This is always a positive. Then I'm going to take whatever this b value is, including the sign. I'm going to divide it by 2 and always square it. Always divide by 2, always square it. 12 divided by 2 is 6. 6 squared is 36. So in this position, I added 36 here. If we add 36 to the right, we got to keep it balanced. We're going to add 36 to the left. 36 and 7, correct me if I'm wrong, is 43. Y plus 43 equals, now I'm going to take this and expand this parenthesis, put just an x in front, 12 divided by 2 is 6. And my last step is move the 43 back over to the other side. And now how do we know if I did this right? Well, I'm going to come back over here and let's check. So I have x squared. I'm going to switch this up. Plus 12, oops, sorry, here. Plus 12x and minus 7. This is the original one. And I believe that when we put it in vertex form, this becomes the quantity x plus 6 quantity squared and minus 43. Let's see if this is right. And we can see they're exactly the same. To work through this is in standard form. Let's write it. This is our last one at this level. So we're going to go from standard to vertex form. I'm going to add 7 to the left-hand side. So I have y plus 7 equals x squared minus 16x plus, always plus, some unknown value. Now, how do I choose this value? I'm going to take whatever the b value is. I'm going to divide it by 2 and square it always. So negative 16 divided by 2 is negative 8. Negative 8 squared is going to be a positive 64. If I added 64 to the right, I must also add 64 to the left-hand side. So I have right now 7 plus 64 is 71. So y plus 71 is on the left. And now how can I rewrite this? Well, I'm going to expand this parenthesis, putting an x on an x squared in front. Negative 16 divided by 2 is negative 8. And a lot of students forget they got to put a square in back. Then I'm going to subtract 71 to the opposite side. I end up with y equals x minus 8 quantity squared minus 71. How do I know if I did it right? These two should produce the exact same shape. They should be equivalent equations in different forms. So I'm going to come up here and write x subtract 8 quantity squared and then subtract 71. We can check they're the exact same thing. Remember, if you were asked to identify some key features here, we can see a y-intercept would be at 0, negative 7, and we would have a vertex. It lies to us and it tells us the truth. So we are moving on now to how the standard grows into the Algebra 3-4 level and eventually the pre-calculus level. What's different about the first few examples compared to this example is now this number in front is not a 1. So students in this class are going to do the color commentary, so you are going to be talking the entire time through this problem. I'm going to remain silent as I do the work. Okay, are you ready? So you're not writing anything down, you're talking. What am I doing next? I should hear you talking. Go. Divided by 2 is 1. 12 divided by 2. So the very first step I did, I took the constant, moved it to the opposite side. Tutors have already written down a couple names for me of groups that haven't been talking. Make sure that when you have another opportunity that you're going to work through this together. So I moved the 10 to the opposite side. Whenever this value is anything other than a positive 1, I've got to factor it out. So I put a 2 down in front. And how do I achieve this? 2 divided by 2 is 1. Bring down the x squared. Positive 12 divided by 2 is 6. Bring down the x. I don't know what this value is yet. I got to figure it out. How do I figure it out? I take this new b value in this trinomial, and I take this b value divided by 2 and square it. Positive 6 divided by 2 is 3. 3 squared is 9. Now notice, this is the largest mistake I see students make. Did I add 9 to the right-hand side? No. 2 times 1 is 2. 2 times 6 is 12. 2 times 9 is 18. I just added how much? 18. So if I added 18 to the right, I must also add it to the left. Negative 10 and 18 is negative 8, or sorry, is positive 8. How do I achieve this? I expand this parenthesis. So this is x plus 3. Remember, not x squared, x plus 3. Here's the 2 in front. I move the 8 back over. This is our next example. Again, the standard is now brought to the Algebra 3-4 level. So you're talking, you're not writing anything down. You're only talking. Ready, get set, and go. What am I doing? What should I be doing next? Make those predictions. Always positive. Divided by 3. Negative 12 divided by 3. This is what I'm focused on. I'm going to take that negative 4 divided by 2 and square it. And negative 4 divided by 2 is negative 2. Negative 2 squared is a positive 4. There's a 3. There's negative 12. This is a positive 12. If I added 12 to the right, I must add 12 to the left. Now I'm going to expand this parenthesis. Always put an x. Negative 4 divided by 2 is negative 2. And very last step, let's move 3 to the opposite side. Y equals 3 times the quantity x minus 2, quantity squared, minus 3. Now I could prove that this is the same as this, or maybe I can show that there's a mistake. So let's come up here and let's write down the original function that was in standard form. This is the original function in standard form, and without a calculator at home, you could still do this exact same thing using Desmos. So I have 3 times the quantity, x minus 2, quantity squared, and minus 3. And we can see, are these exactly the same? Let's turn this back on. We can see they're exactly the same. So let's look at this final example. The very first step we're going to do is move over this constant. So I'm going to go plus 7 and plus 7. Y plus 7 equals 3x squared minus 6x plus some unknown value. Whenever the leading coefficient of this quadratic equation is different than a positive 1, we've got to factor it out. So how do we figure out what goes inside? 3 divided by 3 is 1, bring down the x squared. There should only be a value up front, not a variable. Negative 6 divided by 3 is negative 2, and this is always going to be plus some value. Now, how do we choose that value? We're going to take, and I'm going to focus on the b, and notice that's not just the number, it's going to be the sign in front. So negative 2 divided by 2 and square it. Negative 2 divided by 2 is negative 1. Negative 1 squared is a positive 1. Okay, 3 times 1 is 3. Good. 3 times negative 2 is negative 6. Great. 3 times 1, oh, this is 3. I just added 3 to the right-hand side. I have to also add it to the left-hand side to keep the equations balanced on the left and the right. So I have y plus 10 equals 3 times, and now I'm going to expand this parenthesis, putting only an x in front, and then inside, negative 2 divided by 2 is negative 1. My last step is to move the 10 over to the opposite side, and now I have 3 times the quantity x minus 1 squared, subtract 10. If I plug this in, and I plug this in, I want to verify that these are correct, so let's check. So we have 3x squared minus 6x minus 7, and then, whoops, that did not look right, minus 6x. And then down here, I think it's 3 times the quantity x minus 1 squared minus 10. And we can see that right now the parabolas are not the same, but when I change that last value, it becomes exactly the same. So I just proved to myself that they are, in fact, the exact same functions.